So let's do a little work with circles. So we've been talking about straight lines. Now we're going to get to round, not even lines, but round objects that are circles. So you may be familiar with circles from geometry, but a circle has the following equation. X minus h squared plus y minus k squared equals r squared, where h and k are going to be the location of the center, and your r is going to be the radius, or the distance from the center to any point on the circle. So a couple things to note about this equation. It seems pretty straightforward, but one area that does kind of trip up people is the equation is set up so that you're subtracting your x coordinate. So essentially what I like to tell people is a good way to think about this is just flip the signs when you're writing your center. So if it was -2, we would just use +2 for your h. If it was -9 for the k, we would use +9. Or vice versa. If this was +8, you would flip it to a -8. Just kind of a rule of thumb. And then your radius is being squared here. So if you're given a whole number to find your radius, you're going to have to take the square root of that. So let's just quickly come up with a few. This should be squared, not ×2. So just imagine that's squared. Oops. Let's find the center and radius of the following. So over here, the center is HK. So we just look at the numbers that are being subtracted from x and y. So from x, we see it's a -4, so we just flip that to a +4. For y, it's a +2, so we're just going to flip that to a -2. And we see the center is located at 4, -2. Now the next thing to note is your radius. So you're going to take the number over here. So this would be 25 equals your radius squared. So to find our radius, we'll just take the square root of both sides. The square root and the square cancel to give you r, which means the radius would just be 5. And I'm going to show you how to graph that as well, just for fun on GeoGebra. Let's try that again though. Let's start with our center, HK. So what is our center on this one? What's being subtracted from x? So it's +3, so we need to flip the sign to a -3. Same thing with after y, -9 flips to a +9. So you're just changing the signs on each one of those. And then our radius squared is going to be 100. So again, we just take the square root of both sides. So the radius becomes 10. And we can go ahead and graph these to make sure we did those correctly. There's a couple ways to do it. Now, in GeoGebra, there is an input line, and we haven't talked about this, on the very bottom. So if you click on this input line, you can actually type in equations. So I'm going to go ahead and type in the equation of the first circle, which is x minus 4 squared plus y plus 2 squared equals 25. Okay, so I just typed that into the input, and what you'll notice is that it gave me the lovely ta-da circle. And I can see that the center, I could actually make a point here at +4, -2. That's what we found for the center, and you can see that the radius is 1, 2, 3, 4, 5. So it's a good way to check. There's also a circle tool in here, and if you wanted to, you could just click on the circle with center and radius. Just click on it. Let's do the other one for fun. So what was the other one? -3, 9 was the center. -3, oh, gonna have to move this. Hold on, -3, 9, doop. Okay, and the radius was 10. So type in a radius of 10, hit OK. Wow, that is a big, it's a big circle. There you go. Just a big circle. So kind of something a little bit fun. Play around with it, do different circles. I'm sure even like your kids would like to play around with the circle tool. It's kind of fun. So give that a go and remember to check yourself, right?